Have you ever wondered what the very first question humans ever asked was? What was the first great mystery that stirred the minds of our primitive ancestors? Was it about babies, food, or who's swiping my lunch? Or maybe it was something deeper, like what's the world made of? Our distant predecessors looked up at the moon and the stars, and saw an infinite universe full of endless variety. They saw birds, fish, rocks, trees, and people. All around them was an astonishing diversity of stuff, and they couldn't help but wonder, is all this stuff just different manifestations of some deeper underlying reality? Are the birds and the trees really just water and air in disguise? Or are they composed of something more fundamental? Something truly simple? By the time of the ancient Greeks, the idea that there must be something common underlying all these different things had taken root. In 400 BC, the philosopher Aristotle put forward the idea that everything was made of four elements: earth, air, fire, and water. For him, these weren't like the mythological gods that shared those names. He was saying that they were basic types of stuff, elemental substances that combined in different ways to form everything else. Fire was hot and light, so it must be made of something quick and zippy. Water was wet and heavy, so it must be made of something slow and sluggish. Earth was cold and heavy, so it must be made of something solid and dull. And air was cold and light, so it must be made of something airy and feathery. It was a pretty good guess, though not entirely correct. And by ancient Greek standards, it was impressively testable. You could even weigh the relative amounts of each element in any given thing. If something weighed a lot, it was mostly earth and water. If it weighed very little, it was mostly air and fire. Pretty scientific. But one of Aristotle's students named Democritus didn't buy it. To him, the idea that these four elements combined to make other stuff was just another example of something combining to make something else. So why stop there? Why not say that all stuff is made of a single kind of thing? He called these indivisible particles atoms because atomos means uncuttable in Greek. They were as fundamental as anything could be. That's right, everything is made of tiny hard spheres that are too small to see and cannot be cut into smaller pieces. Yes, Democritus was basically correct too, except he didn't have any evidence that atoms existed. He could just sort of visualize the idea. But sadly, his ideas fell out of favor. For over 1,500 years, the prevailing theory of matter was that it was made of some combination of the four classical elements. This is why astrology became such a popular way to try to figure out what stuff was going to happen next. If you were born under the influence of Mars and Mercury, you would have certain elemental tendencies that would shape your personality and determine your fate. A lot of people found this quite comforting. By understanding the elements, you could supposedly align yourself with them and get the best possible outcome. Maybe it worked a bit, maybe not. Either way, it seemed pretty reasonable. People were comfortable with it. So then why did this scientific revolution happen? What made us cast off these old beliefs and embrace the new weird idea that everything is made of invisible atoms? Well, I think it was a culmination of many factors, both mundane and magical. The medieval period was filled with mystery and uncertainty and hardship, so people turned to alchemy in search of meaning and guidance. Alchemy was a mystical tradition rooted in astrology and the occult, and it held that everything was connected by a fundamental unity. Alchemists dreamed of a universal solvent that could dissolve any material substance and reveal its essence. And they sought to unlock the secrets of the universe through the manipulation of matter. Alchemy wasn't science, but it was sort of a step toward science, because alchemists kept detailed notes of their experiments and their observations, which helped pave the way for the scientific method. Then came the Renaissance, which brought with it a renewed interest in classical philosophy. Ancient Greek texts were rediscovered, including the works of Aristotle and Democritus's idea that matter was made of atoms began to gain traction, especially in England. And as the Renaissance gave way to the scientific revolution in the 17th century, there was a growing desire to explain the natural world through observation and reason rather than through mysticism or theology. And that brings us to the two figures who really kicked off modern chemistry: Robert Boyle and Antoine Lavoisier. Boyle was an Irish natural philosopher who was often referred to as the father of modern chemistry. He was the first to define an element as a substance that could not be broken down into simpler components by ordinary chemical means. Boyle was also the first to appreciate the importance of precision in chemical experiments. He He used a vacuum pump to demonstrate that gases could be compressed and liquefied. He studied the properties of acids and bases, and he discovered that acids could be neutralized by bases to form salts. Boyle's work laid the foundation for the development of modern chemistry, and his approach to science emphasized the importance of observation, experimentation, and quantitative measurement. But while Boyle was doing his work, across the English Channel, Antoine Lavoisier was refining the scientific method. Born in 1743, Lavoisier was a French chemist, and his work had a profound impact on our understanding of chemistry. He was the first to use the metric system in chemical experiments, and he introduced the modern system of chemical nomenclature, which is the set of rules for naming chemical compounds. Lavoisier also made several groundbreaking discoveries, including the identification of oxygen as a distinct element and the determination of the law of conservation of mass. This law states that mass is conserved in chemical reactions, which means that the total mass of the reactants must equal the total mass of the products. Lavoisier arrived at this conclusion by carefully measuring the masses of the reactants and products in a number of chemical reactions. He found that in all cases the mass of the reactants was equal to the mass of the products. This was a revolutionary idea because it overturned the long-standing belief that mass could be created or destroyed in chemical reactions. Lavoisier's work had a profound impact on the development of chemistry, and his approach to science emphasized the importance of precision, accuracy, and quantitative measurement. His work really kicked off modern chemistry, and he's often called the father of it. Pretty cool, right? Now, at this point, the stage was set for someone to take the ideas of Boyle and Lavoisier and combine them with the old Greek idea of atoms. And that's where our boy Democritus comes in. Well, not really our boy. He died around 2,000 years before we started this story. It was actually John Dalton who picked up the baton and ran with it. Born in 1766, Dalton was an English chemist and physicist whose work had a profound impact on our understanding of matter and the behavior of gases. Dalton's most important contribution to science was his development of the atomic theory of matter. This theory, which he published in 1808, was based on the earlier ideas of Democritus and others, but Dalton's version was the first to be supported by experimental evidence. Dalton's atomic theory consists of three main postulates. Matter is made of atoms. All atoms of a given element are identical in mass and chemical properties, and atoms of different elements have different masses and chemical properties. Dalton used this theory to explain a wide range of phenomena, including the law of conservation of mass and the law of definite proportions. The law of definite proportions states that a chemical compound always contains the same proportion of elements by mass. For example, water always contains exactly 88.9% oxygen and 11.1% hydrogen by mass. Dalton's atomic theory provided a simple and elegant explanation for these and other laws of chemistry. It showed that matter was made up of tiny, discrete particles that could combine in different ways to form different compounds. This was a revolutionary idea that transformed our understanding of the nature of matter. So there you have it. From the ancient Greeks to the alchemists, to the pioneers of modern chemistry, the quest to understand the nature of matter has been a long and winding one. We may never know what the very first question humans ever asked was, but we can be grateful for the countless minds that have grappled with the mysteries of the universe, unlocked the secrets of the atom. Until next time, keep thinking, keep questioning, and keep exploring the wonders of our universe. Thank you for watching till the end, and I'll see you next time.